Hey everybody. So this is going to be a bit of a longer video, very likely. I'm going to go into some of the modeling things and try to model what I consider the most complex component of each of the projects, so you have an idea of how I would go about it for each of these, and go through each of them also to sort of talk about where I think you should try to spend your time and try to be as accurate as possible. So we're actually going to start here with what is possibly the most complex project, although having said that, it's a lot of pieces, but most of the pieces are really not terribly complex when it comes to sort of the modeling process for them. So I'm going to skip down to the drawings. The first thing you'll really want to do is download as many of these as you can to your computer. And there's an easy way of doing it, which is if you create a ArcDaily account, you can actually click the View Original Size and then just drag it to your desktop. And that'll give you the highest quality version of this that you can take. You can also, I'm not signed in, so I can't do that right now, but if you right click and you go to open a new tab, it will open and then you can download a version. I don't know if it's quite as high a quality as the View Original Size version, so I definitely recommend doing that, signing in. But let's look at some of these photos. So here we can see it's a fairly complex structure in that there's a lot of pieces. The pieces themselves are actually, I would say, pretty simple. We have some profiles here, some steel. This steel typically is in the sort of wide flange family. So when you're working professionally, you often see this referred to as the sort of W series. So a W12 by 24, for example, is a steel beam and or column that your first number there on the W12, that would be the nominal size, so approximately the height of that thing. And then the next number by 24 in this case would be the weight of that, a section of that that's 1 foot long in pounds. So a W12 by 24 would be approximately 12 inches tall and 24 pounds for a single linear foot of it, just so you have an idea of what those things are. Now, I said nominal, which is different than the weight in actuality. Nominal dimensions, you can think of it the same thing as, a 2x4 is nominally 2 inches by 4 inches, but is actually 1.5 inches by 3.5 inches. So those are just kind of good things to keep in mind. And I'm going to actually provide you guys a couple profiles of some common sort of steel that you can use to get these profiles and extrude them across your model. In general, I'm not really worried about you getting exact sizing on anything, especially these beams. If you can get a beam in, that's great. I'm not super worried about it being exactly the right W series profile and all that kind of stuff. Way too complicated. More just trying to get as much of the sort of structural detail, framing detail as possible. Not worried super much about exactly what it is. But, looking at this, I would make a best effort to try to model the beams, the columns, these little support braces, the framing here and the glazing. Again, try to get as much as you can. This is a more complicated project, so I'm not expecting everyone to get every single piece. But I think, make as much effort as you can is, generally a good sort of principle in general. So I would say the sort of most complicated piece of this, I think the framing is actually fairly simple, is probably this circular little stall, which I'll show you how I went about modeling. It's really not too bad to model something like this. It's a little bit more complicated because it's a non-orthogonal shape, and has a few framing elements on the inside and sort of an outside wrapping material. I'm not really focused on materials for this particular lesson, just really focus on sort of getting the modeling down. So I think everyone should at least try to take a stab at getting this as sort of detailed as possible within this project. So next up we have this guy, the public toilets. Can't remember where these are, but that's all right. So this guy, as you can see here, the plans are really not very detailed. So for your project, when you were working on this one, I'll expect that in plans, you'll have all the detail of the sinks and the toilet stalls and everything else. But where you'll sort of spend the modeling time is really going to be on that framing element. And because there isn't really sort of detail shots other than these sort of elevations and sections, which are going to be helpful for us, you're really going to have to look closely at the actual photographs and then do your best to sort of approximate what you see in the photograph. So, modeling these pieces of wood with the steel bar connecting them, I don't think you need to go in and necessarily model these connection details super detailed. If you want, you certainly can try. Same thing for, the cross bracing that happens here. I think getting in a little bit of detail here and sort of these X's as little steel connectors is great. If you can model this little connection detail as it ties back to the wood, even better. But just try to measure, model as many layers of the construction as you can. Inherently, this one, we don't know the wall construction because there just aren't the details. And I mean the sort of interior gray walls that we see here. So those can just be modeled as just straight extrusions as long as they remain as closed extrusions. But you'll end up spending the detail really, looking at the time on the details, looking at these photographs and sort of trying to accurately model these connections. How does one piece of wood connect to the other? You can see here that this one is dominant over the lower piece as it remains uncut while the lower piece is being cut and supporting that. And then, there might be some connection detail you would want to show there. And of course, the continuous running ties, steel ties that are going the other direction. So this project is a little different than the others because it is built into a hill, which means you'd want to have a little bit more detail about the ground condition, and I'll show you some approximates. We don't actually have all the topography data. I mean, there's a few topo lines here, but it's really not enough to really give us all the information we need. But we can use the sections to kind of make an approximation of the hill, use booleans to cut away so that we can sort of insert our project into that hill, and then build out the detail. The biggest detail here that I think is going to be worthwhile to sort of pay attention to is actually, let's go to a photograph, that. So what you see there is called channel glass. It's a fancy material that is essentially long profiles of extruded glass that fit together that create a wall condition that can either be sort of translucent like this, where you can't quite see through it, which is great for a bathroom. It could be fully transparent, or it can be even more opaque than what we see here. And it's actually, I have a little picture of it right here. Probably shouldn't have clicked that, but you can see it here. So this is a 3D model of what this looks like, but essentially it's 2 C channels of glass that are then fitted together in a particular pattern that keeps an air pocket between them, which is actually great for insulation. Its most famous architectural application is probably this building here. Let me see if is one of these a good example. We'll go to it. So this is Stephen Hall's. That was not the link I thought it was. That's the Nelson Atkins Museum by Stephen Hall. And essentially the entire museum is wrapped in this material, and at nighttime it has a great ethereal glow to it because it's illuminated from the inside, so this box just sort of really elegantly glows in the dark. And it has a very sort of reverse relationship during the day where it's brighter outside, so the box sort of dims in comparison. You can see here a nice picture of someone installing it. It's a really cool material because of its sort of translucency. It also can have some degree of fire rating to it, which is really great to have, as well as a much higher insulation value than when you typically get out of glazing because of that air pocket. So because there's a sort of a separation between the glazing and that thick air pocket, it actually works fairly well for that. And this is the company that, it's the big company that makes it is Pinkleton. If you want to see more projects, it can be really cool to use. But let's go back to that. So modeling that accurately and then trying to get an idea of what the framing that looks like that supports it, I think that's where you should try to spend some time getting a little bit more detailed in this project. Of course, all the other components, modeling as detailed as you can. But, each project probably has 1 or 2 places where I think you want to spend a little bit more time trying to be more detail oriented. And that's, where I'd go for this one. Last up, we have the Nantao public toilets, which has a pretty great document set. Got to say, the fact that they give you the plans, and then, so what is this one? This is just tree locations, the roof plan, as well as the foundation plan, which is really nice to see. So that's a really good amount of information. And some nice photos of construction, so you can actually see how this thing was really put together. And they have that little exploded axon. And then we can see, of course, the thing being built. So for this project, I think it's worthwhile to try to model this sort of framing as much as possible. I wouldn't worry super much about the walls themselves, because the framing there I think is maybe less important. I think if you could get it to be sort of a faceted wall here, notice how that's not a perfectly smooth curve, but is a series of facets. That's sort of what I would aim for. And then try to get that sort of framing. Although we don't see it, I think it's a good thing to try to get that as accurate as possible. It'll show up in a section really nicely. And I think it's just a good exercise to try to build a model with that sort of understanding of the sort of interior construction of it as well. And this actually provides a pretty good amount of information. I mean, this little axon here is really nice to see how these things come together. So when modeling this, I wouldn't, again, worry super much about exactly what these profiles are, because it doesn't really matter that much. Just try to be accurate to, how they generally come together and what the general strategy is. And again, I'll go over specifically building this in Rhino and how I did it. And this section is also useful because we get to see sort of the interior guts. This is an example where, building the interior of this wall is probably less important. So I wouldn't focus as much on that. I would focus trying to get that roof built properly, I think would be where I'd spend my time. And again, you can definitely see the first project, the Mount Tung Yen public toilet, definitely has more detail than others just because so much stuff is exposed. But, as this is graded, we'll certainly keep that in mind, the expectation that anyone doing this project inherently has a bit more complexity. So, there will be some consideration there with grading, not expecting that every single one of these pieces is built perfectly, because, it's just, that would be too time consuming. So focus your time and try to, get as much as you can, but don't worry about it too much. So having said that, so again, this is, as I showed last time, the Barcelona Pavilion that I was using in the sheet views and a perspective. But let's talk about these projects. So first, I guess we'll start with the Nan Tao. So as I mentioned, the first thing you really need to do is download all of your views that you can get, which I have actually already saved and should have had open already, but I'll get to it. I think it's under links here. Yep. So these were all just downloaded from Mark Daly. To bring them in, the easiest way that I always find is just dragging them in. Sometimes you may have to do a different command. I believe I'll have to get back to you on that, what the command is. But in the older version of the Mac version, it doesn't allow you to drag directly in, but you have to place an image. And I'll look that up and post it somewhere just in case anyone has trouble with that. But essentially, drag it in. Don't worry about the scale when you first bring it in. And this is kind of a quick version of and something we've already covered previously, but since these are in meters, we'll have to make a few adjustments to make them work properly. So I'm just going to hit the scale button, and I think all of these have something to scale on them, although it's different per project. So this one, of course, gives us in meters here. I'm just going to click where the 0 is, and then click where the 10 is, and type in 10 M. And Rhino will understand that you're referring to meters here. Hit enter, and that will scale that drawing up. Okay, so now that we have this guy scaled, of course we'll bring in the elevation, or the section in this case. I'm just going to hit ZS to zoom back into this guy. And we can see it's very convenient. It gives us a little key that shows us where this is cut. And this was a little tricky because it's not exactly cut on the 90-degree orthogonal axes. So I had to get a little creative about that in order to get that one set up right, which was basically made a copy of it, rotated it so I could lay it flat. I'll just do this in plan real quick. All right, so essentially I just used this guy and scaled it up and rotated it so that I could match it up to the project. And then once I got it matched, which of course I'll have to kind of compare, so that seems to be the same configuration. I used this line as a reference, so just drew a line and extended it across. And then you can see here I've already done that, and I have this line. So basically I used that to align the section so I could get it to fit to the same profile. I did have trouble with this guy. It didn't exactly match the way I was expecting, but that's okay. It doesn't have to be perfect. So even when I place it here, you can see it doesn't quite fit the way you would expect. This piece is kind of off compared to that one. And I think their key just isn't exactly right. So as long as both of them are scaled appropriately, which this one also has a scale of 10 meters, we can use it for what's really going to be helpful, which is more of getting heights and things. This project's fairly simple. So as I said, I think the thing to try to model as accurately as possible is really going to be this guy, the actual roof itself. So I'm actually just going to start by, I know the roof profile is basically this little arc shape here. I'm going to use the arc command. I have project currently turned on. Well, then I'll just make sure that I'm drawing only on one surface. And with arc, I'm actually going to use the start point. So click up here in the upper left-hand corner. So I can tell it where the arc starts. And then I'm going to do through point, which tells Rhino that the arc needs to go through this point. And then anywhere I connect it, it'll match that arc. So now I have one side. I'm just going to mirror it. So the mirror command right across. So looks like I wasn't super perfect, but you know, maybe I could go back and adjust this a little bit. I'm not going to worry about it too much for right now. So actually, I'm just going to hide or move these things aside, the things I already made, and come back to them, referencing them as I build them. But really just going to focus on the roof right now. So there's going to be a lot of transitioning between views. So in this case, I'm just going to hide everything else actually, because there's too many things in this model, because I have all the different models going right now, which is a little chaotic. I'm going to use my favorite command here, which is the isolate objects command, so that only these things remain. And let's see if we zoom into this view. There we go. Now we get a view of that elevation that's a little bit more helpful. So I'm going to select these curves again, and in this case, I'm going to make a copy of them and bring them up to where the roof, let's go for the top of the flat portion of the roof. So you may notice this roof has one portion that's flat and one portion that angles up. The portion that angles up seems to be on the side that's facing inwards, and I think we can confirm that just by looking at the photographs. So again, this is a good example of where going back and forth between photographs is really going to be helpful. But let's see here. So that doesn't tell us. But yeah, here we go. So you can see that it's fairly open in this direction and maybe less so in the other. I think that's, yeah, that seems to be the way it's working. And if we were to look at that axon that's provided, we can see here that in the steel beam profile, one of them is flat and one of them is angled. So to make that, I'm just going to get an approximation of what that shape is. So I know the first arc here needs to be angled up. So I'm actually just going to take the middle control point, and looking in the front view down here, I'm just going to bring that guy up until the line seems to get to about where the peak is. And I'm referencing this peak over here. So now we have two curves. Go back to this perspective view. It's going to draw a line actually down the center, turning off project. So if we were to, we could pretty quickly just make these into a planar surf. So that's kind of one of the surfaces, and then the other, I think this will still make a planar surf. Yeah. So you can see here, that's kind of the general, flattened version of what we're going to be making. So I just hit ZS again, of course, always doing that to sort of zoom into what I'm working on. So that's, I'm actually going to delete these. These are just so I can sort of see again what I need to start working on this. Oops, deleted the wrong thing. So that's actually a good reason why I always try to lock the layer that the drawings are on. These are actually not on the correct layer, so I'm going to move them down here, and now it's locked. So now I can't, now I can't, yeah. No matter what I do, I can't drag those guys around, which gets real annoying. So I'm going to select, let's see, I will select this curve and this curve. And I'm actually going to, looking at the axon, I can figure out how many structural pieces there are. So I can see here there's 1, 2, 3, 4, 5, 6, 7, 8. Is that right? 1, 2, 3, 4. Yeah, there's 8 structural pieces, which actually means that we need to divide this curve into 10 because of the start points and end points. So we'll just divide, at least I think I did that right. So we should have equally divided points along these curves. So as long as I get 8 points when I do this, which I can go to properties, so you have 9. So actually I did my math wrong. I don't know why I thought it was 10. Let's try it again. So let's just divide this and this guy. And this time we'll do 9. So now you can see we have 9 points here, or 8 points here, and 8 points on the other side. I'm just going to start connecting these with some lines, and this is actually basically going to be the lines of our structure. Each time you hear that click, that's just me hitting the return key to end the operation and start the operation again. So we're already actually getting pretty far along in modeling this. The next thing that we're going to want to do is bring over some profiles. So I will have linked a document that includes these profiles. These are wide flange profiles. So these are actually based on, I can't remember what sizes I gave you, but 3 different sizes. I'm not too worried about being super precise about this. And in fact, we'll be modifying these as I sort of see fit for each project. Again, just trying to get the essence of how something works more so than being exact. So I'm going to pull this guy over and then go to plan view, because I want to rotate this to be aligned. So I'm just going to type in rotate and align, and then 90 degrees. Because essentially I'm going to be doing a loft using 3 different profiles. So again, if we pull up that image, we can see here that it's thickest in the center and thins out at the either end. So we know we're going to want sort of a larger version of this thing in the center, and then it's going to get smaller as it goes to the either side. And actually this sort of plane that we have here is a good reference point for the top of our structure in this case. So I'm actually going to lower this guy because we know we want one side to be perfectly flat. So I'm actually just going to do M and then hit V. You can also click up here. That will make my move command only work on the Z axis, on the vertical axes. So bring that guy there. Now I will copy it across to my one of my points on the edge. So I know, again, looking at this guy, that it seems either end is the same size and the center is bigger. So I'm actually just going to kind of cheat here and pull this guy down to make this a bit bigger. If I were being precise, I would probably be looking at the section here and seeing if there's information that I could copy. So just generally looking, it looks like the beam is there. Again, these aren't super clean, so you can see there's a little bit of detail that's missing, but I can use that as a reference and just make sure that I pull it down to pretty close to that. I'm not being 100% precise because it doesn't matter too much. Oops, don't do whatever I just did. Although a funny looking beam. So that's going to be one of our beams. The end conditions. So I'm just going to move the points, and I'm not actually going to scale this thing because I want to keep the width the same. As far as I could tell, the widths of these beams were the same. It was just the profile was shrinking in height. So once I've done one side, I can actually just use the copy command to copy this to my other point. And that will actually be what I'd use to make a loft command. So if we select these 3 3 closed curves, type in loft. You can see here that there's a line that connects them. So we want this line to be on the same part of each of these with the arrow going the same direction. So if we look over here, it's on the lowest corner of that profile. Here it's on the upper corner of that profile. So I'm going to pull that guy down. This one's really in the wrong place, so just drag this down. Now we need to check the arrows. So 2 of them are up and 1 of them's down. So all we have to do to flip that is up here we can press the flip command on the upper left-hand corner and just flip this one. So now there's a continuous line connecting these things and all the arrows are going the same direction. It's kind of hard to see in the white background, but there they are. I want to set the loft command to do straight sections and just hit OK. So now we have a little beam that I'd say is pretty accurate to what's actually there. And essentially the process to do this for each of these would be to copy, not the point, but the profile. Now you may notice that this beam is not currently a solid, so all you have to do to make it a solid, because the end will be open, is type in the command cap, and that'll make that into a beam. So all I have to do is just copy, well, I'll actually just take one at a time. So I know all these beams are basically parallel to each other, so all I got to do is take that end profile and copy it to each of the points that I determine where the structure ends. So here and here. Now I'm not going to do the whole thing right now. I'm just going to do half. And I know either end is the same. And then we need that middle profile, which we don't have points to necessarily attach to right now. So I'm actually just going to, in plan, use these lines themselves. So with perpendicular on, I can match them pretty closely. That should have worked, right? For a reason, that's not working the way I was expecting. So we'll have to find a way to match that to the center of each one of these. How did I do it last time? So we could divide this guy up, or the edge here, but that probably won't work because it's not going to be exactly the same division because it's an arc versus a straight line. So let's just try dragging across. All right, that worked. I don't know what I was doing wrong before. The height might be off. So again, using the move command with the vertical axis, hitting V so it only moves along the vertical axes. And then just move this down so that it's at the same height. And again, perform the same loft command operation. Again, that time I didn't straighten out those arrows, so you can see it fails pretty badly. So I'd want to go in and straighten those out. I'm not going to bother doing that right now because I think you guys get the general idea. Since this is actually mirrored, I really only need to do it for half the side, and then I can mirror that over. And then I basically want to do, the rest of the structure is actually fairly simple. Looks like I got shifted from the plan here, but that's all right. If we again go back to that little axon, where did I have that? Here it is. We can see that we just have a straight beam here, and a straight beam running across. So that's really just going to be, we don't need to do loft at that point. We can just sort of place our profile. Again, I'm going to use this same guy here. Place him at the end and rotate him 90 degrees and just do extrude curve. So basically we just want to repeat that process until we have built all the little structure for this. Once we have that done, we'll want to build the surfaces on either side. Now it's not shown here, but if we look at this detail, you can see there is a surface sitting on top and a surface kind of floating below. I'm just going to do a quick approximation of these. I'm not going to worry too much about them. In fact, these little surfaces that we made in the beginning are actually already working fairly well as our top and bottom. I currently have ghosted mode on, by the way, so that's why you can see them. My shaded mode may look a little different than yours because I've edited it for this purpose, but you can see it here. Now we could just quite literally drag these down, again, locking them to the vertical axis, as they are functionally mirrored on the bottom. Now it has to be a little lower because you can see it's colliding there, which really isn't our intent. And that's actually not quite perfect because we would need to really adjust the curve that's defining this. As you can see here, let's zoom in on the appropriate section. I'll have to hide these drawings. They're getting in my way. So again, because of layer management, I can just easily hide them. And we'll go to not the right section, but you can see here that these profiles aren't actually parallel. You would actually want this one to be higher. So let's just try pulling down that curve instead. And pull down. And now I'm just going to edit the point of that curve so I can bring it up more in line with what I expect for that underside surface. Maybe even a little higher. Okay. And now I'm just going to isolate this guy real quick because it's going to be easier. But if I draw a line between these, I now have multiple edges, so I can do planar surf. And then I have the underside. Now, if I'm being super detailed, I could also, panelize that. Need to drop down a little bit. Again, if these things don't have any three-dimensionality to them, so each one of these I would want to do, extrude in this case, surface, and give them some thickness. So how about 0.5 inches? Now that has some actual materiality thickness to it. Again, these need to lower so they can fit beneath that beam. And we'll do the opposite. Extrude and surface and 0.5. So basically repeating that process, creating that structure, that should be sort of the basics of this guy. As far as making the walls, again, using the arc command to sort of make the basic wall, then come in and maybe you can find a way to sort of make that faceted, again, sort of the way that we see the project is in real life, looking through the photos. So you'd want to do something similar also for those sort of foundation conditions, but that's the majority of the project. And the nice thing is, these three things are pretty similar. So, once you figure out the strategy once, in fact, I would probably just copy the steel over and scale it to fit each one because it's going to be pretty similar to that, and that would be close enough. So you really only have to do this maybe once and then maybe make some adjustments to it. But that gives you, if we were to take a nice section of this, we have all solid closed geometry, and if we don't, we just want to make sure that it is. These profiles are closed. These surfaces, so it didn't eliminate the surface when I was doing the surface extrusion, so I'd want to do that, but just so I don't have more than necessary. But everything here is closed, and this sort of solid assembly is pretty realistic to how we build something in real life. Okay, so that's it for that project. Of course, there's more to do, but I'm just going to try to cover what I consider the challenging bits of each. Okay, sorry for the jump. I had to pause the recording for a moment to take care of some things. But now I'm back. So we're going to move on from the Nantal Pavilion and I suppose work on the next one, which is, the complicated one. Not too bad though. I had some fun modeling this guy. So again, bring in your drawings same way, get them scaled and get them sort of placed as well as you can where you think they go. So although I'm a big advocate of layer management, I actually had some terrible layer management when building this, but it's okay because I can go back and reassign layers, which will be very helpful later on. But so I have the majority of the framing here, not everything, but majority. And I also built, these little bathroom units pretty decently, I'd say. Again, I'll share with you a file that has some profiles in it, so you'll have these. And they're not super accurate. I really wasn't paying super close attention to exactly the sizing of things. I was really just trying to get it close enough to the drawings. And I'm sure, there's some inaccuracies here, but it's plenty close for our needs. So I'm just going to turn everything else off so we can just look at this guy and how it's modeled so far. So obviously there's still a few things missing. So if I really be in detail, I'd come back and, finish out with as much as possible. But, this alone, I think, anyone gets to this level, I think that's great. The more detail, of course, the better. And I think, the reason we're doing this is really because of the sort of experience you can get out of trying to model something complicated like this and figuring out how to do each of those steps. So similar to what I just showed with the Nantal, this is a lot about just sort of taking that profile, getting it approximately to the size you want by sort of stretching it using the control points, and then just making extrusions. However, in this case, what I did was actually, since all the frames are exactly the same, I really only had to make one. So in this case, I've double clicked it because that was a block. And once I'm in the block, I can edit things. So let's say I realize that, so this column probably realistically goes through that concrete that you see there and is actually sitting directly on this lower beam. Now, I don't have enough detail per se to 100% guarantee that that's the way it works, but this will be close enough. So I'm going to use the move face command and just select the bottom face here. There's some constraints here. I usually use normal. You can set it to normal or none, but normal generally, that's just going to move perpendicular to that face. So I'm just going to bring that down, and now that column is sitting on there. So if we were to look at any others, they're not currently like that, but once we hit OK, all of those columns are going to shift down and have that same relationship. And that's, part of the beauty of using blocks. So let's just move this guy aside for a second, and I'll go over how I did a lot of the basics in this. I'm going to turn back on the drawing imports, so you can see here that I have these kind of lined up and matched up as best I can. And I also have a approximation of the topography, which in this case was I literally just drafted the topography as seen in section and extruded it. It's just one continuous profile. I'm not needing to be more precise than that. I mean, I'm sure certainly could be, but for this purpose, that's basically it. I'm going to also move that guy. I'm just actually going to hide him. Not necessary right now. So again, the best way to do this modeling is really going to be shifting between your views. The 4 views here, this is where this sort of stuff comes really into play and becomes really useful. So I'm going to start by just drafting out where my general profiles are going to be. So what's the general shape of that inside volume? And this is just going to be for reference for me, but it is helpful to have. It also sets some angles that I can use as reference points moving on. So I have that. You can see it's not sitting against the picture here because I was drawing on project. And right now you can see in the distance, my C-plane actually was running through the center here. So with project on, you're just always drawing on the C-plane, regardless of whatever else is happening, whether you're in an elevation view or top view. But what I'm actually going to need is one of those profiles, which unfortunately I just hid, but I'm going to steal one real quick. So there's a great command called DAAP face border. And essentially what that'll give me is any surface I select, which it's not letting me select. Oh, that's because it's a block. All right, I'm going to have to unhide some stuff and grab one of these profiles back from over here. Let's see. I'll take this guy. And again, I will send you guys a file that I will go through in a second that has all this stuff in it. But I just need to keep these around so I can reference them. Okay, so now unlock this so that I can select it, and I'll just hide everything else. Again, this is only a really problem because I have so many models going on right now. Now, where did that little profile get to? Well, either way, here's one. I think I lost it already. So looking at this, I know I need sort of a column going up, a beam going across, and a column going back down. So there's some terminology we should just get straight here. I hear a lot of different terms for these things. A lot of people call everything here a beam, but everything here is not a beam. So there are essentially, when you have horizontal structures, you primarily have beams and joists. Beams are going to be your larger members. So if you see here, this beam is actually connecting between the columns. We have joists sitting on top of that beam. Now they are running between beams, and because they're running between beams and not between columns, they're most likely a joist in this case. And of course, columns here are any sort of structural member that is vertical in general, unless it's not actually taking any weight, in which case it's not really structural. But it's good to sort of get that terminology, get used to using that terminology. It's something you'll obviously hear over and over again. So I've just rotated this guy around. I'm going to turn project off so that I can just select the actual point and move it there. Now clearly, you can see by the profile, it is much larger than necessary. And actually, we'll zoom in here, and we can see that it is indeed much larger than necessary. Of course, my plan view is not quite so detailed as to actually know what size it really needed to be. But I'm just going to do actually a standard scale in this case. Not scale 2D because I kind of want the whole thing to shrink a bit because I know it's probably pretty far off. But let's just say that that is close enough. Again, not being really precise here, but that's okay. So now I'm actually just going to, since this is a vertical column, just do a standard extrusion, pull that guy up. Now we have one of our columns. I'm going to hide this guy again. Don't need him right now. Take that same profile, and now I need to make, let's see, what do I need to make next? I need to make, how about that top beam? So just going to copy it up using the center point. Hopefully I clicked the right one. I didn't, but we'll get close enough. So again, I'm always typing in ZS to get closer to what I'm working on, because it's much easier than trying to work on something that's really far away. So that'll do that. So if I just do extrude right now, it probably won't be that useful because it will extrude straight across, which I could do. In fact, I probably will in this case, actually. So I'm just going to extrude straight across because this is going to be easier than trying to extrude along a profile. And then go into the side view and just use the standard rotation command. In this case, I'll turn on project. Pick the point where it's making contact with that curve that it needs to follow. And you may notice that I made this significantly longer than necessary, and that's going to be okay. I did that intentionally so that I could cut that beam. So you can see here it is cut at an angle, the angle meeting that the column itself. So I'm actually just going to create a surface that can cut this guy. So you can see here in 3D, I just made a box that's fitting that same angle. So now I can do a Boolean difference, and that guy's now cut. So for the column on the other side, I'll actually just, again, do this the easy way and just copy the first column over, make sure it's lined up the way I want, which it is. And now we will rotate the same way using the elevation view to align this column to our angle that we already set up. That's why having that little reference geometry is really useful. And again, so this guy isn't quite tall enough. I'm going to use the scale 1D. You could also use that move face command that I used earlier. Turn off project. So I'm constantly turning on and off project because it's useful sometimes and really unhelpful others. And in this case, I know how tall it is because I can reference it here. So I'll just put it, it's kind of hard to tell. Do you think if that beam is actually perpendicular or aligned to the column? But either way, I'll just do that for now. So that's our sort of basic structure, actually. We've already done a good amount of this. Now we could, if we were being precise, extend this further, then cut it the same way. Maybe I'll do that later, but for now, I'll just let that be. And I'm really only going to work on the structure that's running in this direction right now because I want that to be a block so that I can copy that. The structure running perpendicular to this, I'm not worried about right now, and I'll come back to it. So this is where we're going to have to go back to the photographs of this project and try to get an idea of, this section doesn't show us everything we might want to know. So this photo here, here's a good one. We can see that there's sort of layering of the beams underneath. It looks like these beams run all the way underneath, and then we actually have that concrete slab sitting on top of that. And then those beams are sitting on some larger beams below, which are then connecting to these columns. And the columns are kind of irregular shapes. They're just tubes, but they're sort of, going down at different angles. Not going to worry about them super much right now, at least for this demo. But we know we need to connect some beams across. So it looks like that's these beams here, which might be a little bit larger because they're taking more weight. So I'm actually going to find that original profile that I used, which is right there. And let's rotate it using the gumball. And again, if your gumball doesn't appear, just make sure it's turned on down here. I typically work with gumball turned on, my O-snaps turned on here, ortho turned on so I can move along axes, which is of course very useful, and smart track. Although smart track can be a little annoying sometimes, I do find it pretty useful most of the time. So I'm just bringing that down. Now I can see in section that it is indeed a little too small. So I'll initially just try scaling it and see how that looks. That probably makes it too big. You can see the flanges, which are these bottom pieces, were getting too large. So I'm actually just going to drag this guy down. And again, all approximates, not really caring too much. If we were building this project in real life, we would use actual set profiles, but we're not. We're just building it for the sake of this project. So I said I wasn't going to extrude structure that is that's running perpendicular, but I kind of lied. So I'm just going to extrude this guy just for reference, really, actually, because I wanted to be able to extrude going the other direction and just have that as a reference point. So I'm just going to snap this point to our original column. And now I can extrude this guy across and align it to the underside here. So you can see here, we'd also want to do the same operation we did before of just create a object to Boolean this, which I'll just do real quickly. So Boolean difference, select this guy, and now it's nicely cut. So that join worked perfectly. So this is the majority of the structure that I had here. The other thing that I had was this little connecting piece there, that little framing thing that we can see in the elevation. And that one was actually super simple. So I'm just going to turn on project and draw the center lines of where these bar members are. And it looks to be like that. And another one here. And then once I have those selected, type in the command pipe. And it looks like I'm going with a diameter of 1 inch. That's fine. Just hit enter. And we get that little piece of geometry, which, because I was working on the C-plane, is actually already aligned to the center there, which is pretty perfect. Anyway, so once I am happy with the elements that I know are along this sort of grid axes, I'm going to type in the command block, just block by itself. It'll ask for a base point, which you just want to use sort of a reference point somewhere on the model. It doesn't actually matter terribly much where you do, at least for what we're doing now. I'm just going to click there and then name this something. Good to keep organized. Again, all good practices. So now I can go to plan. Let's see, I need to align this to actually where it's going to be, which would be right there. Actually, I'm going to go to the last one, and I'll show you why. So that's aligned there. And then I'm going to do the array linear command, which is, I know I need 10 bays actually. So that. And now I already have 10 bays of structure. So detailing one piece fairly nicely meant that I get to copy it, and then I have 10 perfect details. And of course, the other great thing is these are all blocks. So if I change one, if I decide this guy wasn't done correctly, it needs to shift, just hit OK. They all shift. So, a good way to sort of get a lot of detail pretty quickly. If we were to look at this, so this section doesn't show it, but there are, you can kind of tell there was another column that sits along where we're seeing through this toilet here, and that's something you want to model as well. But let's talk about this toilet. So I'm going to hide these things so we can just talk about this, because it's a little bit of an unusual shape. It is round, which makes it seem like it wouldn't be too hard to model, but there are some trickiness to it. So I'm going to turn on project again, and I'm just going to draw a line across where I know I want this to, the sort of diameter of it. I'm then going to do a circle, and just in with project off and sort of 3D space, just use that as a reference for a circle. And I'll get rid of that first line. So basically, I was able to draw a circle using that as a reference. I'm going to now copy this up. So the object is circular until it gets to about this point, and then it begins to taper off. So I'm going to put in 2 more circles. So it looks like it's pretty consistent through here, but it does need to be rotated. So I will do a rotation in the elevation here, or section I should say. Tilt that guy up. And then this guy needs to be also tilted. Of course, it's the wrong size right now, but I'll fix that momentarily. And now I'm just going to do a scale command, just scale, not scale 1D or anything. Connect the 2 points, and again, I'm using the perspective now, just so I can snap to what I want to. And then it looks like it didn't work exactly the way I wanted, but I'll do that one more time and see if I can get that a little bit closer. So now you can see I have a circle that is where it should be in sort of 3-dimensional space. I have next reference point and next one. So we're just going to do a simple off command. You can see looks like all of my arrows are aligned and they're going the right direction, so I don't have to do anything this time. Hit enter, and okay. So I wanted to use straight sections again. That way it keeps that sort of straight profile that we have. Now this is a thin material, so it has no thickness right now. So we'd want to eventually do the sort of offset surface. Let's try that one more time. Offset and down to surf. And we'll do 0.25. So 1/4 inch. And hit enter. So now if we look at this thing up close, we can see it has a degree of thickness to it, just like it would in real life. Okay, so that's the first thing. So I'm actually going to, in the side view, turn on wireframe so I can see through that. So I can see there is some structural pieces that, if we look at the photos, again, this is where looking between the photos and the drawings will help you really clarify what some of the things are. But we have these, what look like L channels, which is a common steel channel that we would use. So I'm just going to draw out, again, in the project mode, what I think that is. And this is super blurry, so I'm just going to get as close as I think it can. I think it looks something like this. I'm not super worried about it being perfect, but that's generally what I think is going to be pretty accurate. So I want to make these into objects. So I'm actually going to do the revolve command, which is this guy here. It's going to ask me for the center of my axes, which I want to use the center of the first circle that I drew. So I'm going to reference that. And then basically it asks for degrees, start with 0, end with 360. And oops, you can see here it did not work the way I expected. So let's try that one more time. So I think what I did wrong was it wanted an axes. So it started with, it's really hard to see right now. So let's turn project off. So I want to use the center point, and I need to draw a vertical axis because it needs to know when it needs to rotate around. So I'm just going to go to the front view now and select. So you can see that in the upper right-hand corner, I'm drawing a vertical line based on that circle. Now it asks about rotation, so starting rotation, and then just hit enter if it's set to 360 already, or type 360, and it'll create a perfect little circle. Now again, we can do the same thing as before, the array linear command. Going to turn project back on, so I'm not snapping anything I don't think I am. And there you go. And all of a sudden, we have a decent amount of structure. So of course, we'll have to fix these guys up here. So I'll just delete them now. But we have this sort of basic barrel structure. Now to get a little bit more detailed, we need to know, we need to cut open a door. So I'm actually just going to go to plan and figure out the door seems to be about yay big, and then I will pull that up to the height that appears to be in the model, which looks like just below this guy. So now, again, I'm just going to select all these, do a Boolean difference, select this guy as my subtractor, and there we go. We cut them. So we could also do Boolean split if we want to keep that door panel. So Boolean difference will remove things, Boolean split will just split them. So let's try Boolean split real quick. Boolean split, and it seems it didn't like that. Boolean is a finicky operation. Sometimes just moving things just a little bit. So I'm just gonna move that guy down just a teensy bit. I think because it was perfectly aligning to the edge of that top beam. So let's try Boolean split. Now we have a door. We can eliminate these little pieces on the inside. We don't need those. I don't think they were part of the door. Actually, they are. You can kind of see them in the shadow there. So I will actually just select the door and type group. Because now what we can do is we'll just do a simple rotation. And I'm going to turn these backgrounds off because they're too hard to see. Turn off project. And you can see here we now have a functional door that has some structural pieces as part of it. That's 90% of this guy. Now we'd want to, these curves up here we probably can't do revolve on. So what we might actually have to do is take that same profile, bring it up here, and do a sweep command. Now a sweep may not work very well on a circle. Sometimes I find it's easiest to split that circle in half, in which case I would just do connect these dots and type in split objects to split. So we'll use that curve, and then we'll use objects to split. Yep. And then next cutting objects, this guy. So now we should get that little semicircle. So if we can find our original profile, which I think is right here, I'm just going to bring that up and align it to the edge there. Let's see. So that's where it should be. So we have the curve and we have the profile. So now we just want to do the command sweep. We'll just do sweep 1, ask for the rail, and we'll do this guy, and ask for the cross section. We'll do that guy, and we'll hit enter. And let's just leave it at the default. I'm going to set it to road-like so it remains vertical. And now we have this guy. I'm going to hit cap so it makes it into a solid. And then to copy it across, I will just mirror it. But you can see here, we now have a very nice, consistent profile moving along that curve, even though it's angled. So we can do that for the top. And in general, that's how you model most of this. The other things I was going to cover on this guy real quick, and I know this video is getting long. So fortunately, the other projects are a little easier. And this covers a lot of stuff. Let's just talk about, so here we have a sort of concrete slab with metal decking as its base. So this is a common thing you might see. The way I typically would draw this is actually just draw the basic shape like so. And then I would draw one of these guys. These are sort of the cutouts where that metal decking is forming the underside. And then simply do an array command and do that. And then using these guys, I'm just going to do the first 3, type in trim between them, and then join all that. So now we have one shape that we can extrude. So that's how you can make that metal decking pretty easily and pretty nice and accurately too. Okay, so I think that's most things. I'm also going to just mention, come back here. There's a website that might be helpful for you guys, which is called Flying Architecture. So they're a rendering company, I think, but they also have, not store, how about studio? Is this where it is? Somewhere around here. I was just here. Well, let's look at, okay, maybe it is under store. So 3D models, we'll do free only, so you don't have to pay for anything. And then we'll go to sanitary, and there are some toilets here. So the great thing about Flying Architecture as opposed to most other 3D asset sites is that everything they have is already a Rhino model, so it already works really well in Rhino. You do not need to have precise toilets. I think it might be worthwhile to download, say, one toilet and then just use that and not worry specifically if it's wrong or right, or, you know, some of your toilets might be the squat style toilet, some might not, some might be this, some might be wall hungs or things like that. I think as long as you get one in, you know, it's a good way to just sort of test and bring that model in. These are pretty simple, so they work pretty nicely for that. So I've already brought one in the version that I finished earlier, and you can see there's just a toilet in there. Not exactly what, you know, was in the original, but gives you an idea and is a sort of placeholder. Okay, so I need to keep going. So we're going to stop with this guy, and again, I'll probably make some more supplementals as questions come up, but just going to try to get through each of these projects real quick. So looking at this guy, you know, the frame you'd want to build the same way as the last ones we were talking about. So once you build this thing, you can make it into an array, which you could then, so this is the sort of bigger structural piece. So take this guy and there you go. So then you want to infill between that. Of course, I didn't do as many as there were with the lighter structural pieces. If you look at the photographs, they are different size pieces of wood. The next thing you want to do is I've actually already drafted up just the sort of basic shape of this. I actually ignored the doors because I know the doors aren't full height. So I'm just getting the basic shape. So we'll unhide everything again. You can see here, just kind of ignore those doors. Those are the basic shapes of the interior volumes and the exterior. Going to do a nice extrude curve on this, and I'm going to make it taller than need be, which I didn't actually make it quite tall enough. So real quick, scale 1D. I want this guy to be taller than necessary. So there you go. The reason being is if we look at the elevation that we have here, we can see it is actually cut off, so it doesn't go all the way up. I've already aligned these elevations. So I'm just going to select everything here and do the classic isolate and move over to where that is. So let me, looks like this guy's on the wrong side, so we'll pull that over here. Or is it the right side? It was in the right place. So I'm actually going to hide everything other than my original block. I didn't draw those the first time very accurately to dimension. I was just kind of guessing. But I am going to draw them accurately now. So using project, of course, going to just draw the outline of the inside of this sort of shape so that I can use that as a reference. I'm actually only going to draw one side. Of course, where did it go? So because I was drawing on project, it was way back here. So I'm just going to move this guy back. So now you can see that's the profile I drew. Actually just going to mirror it. I always want to mirror in circumstances like this so I can make sure it's exactly the same side to side. And I'll join those. Now I can see that basically I need to cut back that building volume that I already have. So I'm just going to offset this. And I'm turning cap off in this case. And that's not quite enough. So let's offset, how about 6 inches? That looks pretty good. So now I know that that's the sort of general profile that that building needs to fit within. So I'm going to select both of these and pull them over. So I can actually, I think this will work if I just type trim and then hit that. Yep. So if, so long as you're in one of these views, it will trim even though they're not actually attached. And if we zoom in here, we can see we trimmed that. The only difficulty is we trimmed it and it did so without keeping these things as solids. So we could have done that another way, which would keep them as a solid, which would be to do a Boolean, which you cannot do a Boolean just by using a curve. Booleans have to intersect poly surfaces or closed surfaces. So this time I'm just going to offset and do a big offset, say 10 feet, and do it outwards. Actually, let's do that again. Offset, and this time I'm going to do cap. Flat. And what that'll do is make it into one shape. So now I can do an extrusion with this. So I extruded that profile. So now I have a large solid object. So if I do a Boolean difference this time, you can see that it now keeps those things as solid objects. And that's preferable in all circumstances. Now for the doors themselves, I would want to come back and cut these out. I didn't want them to be, the full height of the building, so I'm actually just going to come back in by creating a little box, and let's just call these 8 feet tall. So now I can just do another Boolean, and voila. So one thing you might notice is we actually ended up with nothing. Sometimes you might want to make it a little bit bigger because if I didn't do it exactly right, I might have a thin, basically non-existent surface right in the ground there, which is not something I'd want. And then I'd want to do 2D drafting for these doors or 3D draft them as sort of physical objects. But that's how I'd make this. And then I need to put a roof in here, which the roof sits within the object. So the way I'd probably do that is actually just similarly to how I just did that thing of making an object. So I know into roof profiles like that. Let's see, offset. I typically, as suggested, do how about an 18-inch roof? So do that. So that will give me the profile. And now I need to extrude. And then I could either Boolean join these if I want them to be the same thing, or I could Boolean difference, where essentially remove anything but these sort of infill panels. So now we have a roof and everything's solid. Get rid of that original curve. And again, I think all the modeling you need to do for this framework is really the same as what we were doing for the other project, so I'm not going to go over that too much detail. The one thing I will say is this project didn't have anything for scale. So what I did was just pick the door, any door, and use that as a scaling object, just assuming that a typical door is 3 feet wide. This may not be, but it'll be close enough for us. Just connect those dots, type in 3 feet. Now let's scale to that. Okay, so we'll leave that project now. Try to finish this thing up. What was the last one that I haven't done? So I did Nantal, I did that guy. Oh yeah. So the only real complicated thing here is that you have a ground condition. So all I did here was copy the profile, aligning these things. So again, the dimensions here are in meters. And getting these things to be exactly the same was a little tricky, but just pay attention to make sure the drawings match up each other. I just simply took that same profile, copied it 3 times at 3 different locations. So right there, there, and there. And just did a loft command. Not the most accurate ground surface ever, but it is, we'll just do a loose, no. Yeah, normal. Normal's fine. There's some weirdness going on, but that's okay. Again, it's not super perfect, but once you create that thing, type in cap, make sure it's a solid. And then the next thing to do would be actually to make I'm just gonna hide this for a second, but since we're cutting into the ground, I would actually want to make a object to cut with. So in plan, simply all I did was, so maybe draft this thing first. So you have it as a reference point, but essentially I just went around. I'm only going to do a big piece right now. but you would want to do this for the whole object. Create, not what I just did, because I didn't do a flat curve. Always want to be drafting when you're doing 2D stuff with project on. So let's do that one more time. And again, I would just do the whole building and not just this area. But I just wanted to make the sort of negative space that I want to extrude out of that hill. And I will unhide the top one. Align this to where it needs to be in the elevation. So the building sits about there. And now I can just do Boolean, difference, that guy. So essentially I made a cutout for our building to fit in. So that's the one thing. The other thing is that channel glass, which I'm just going to show you how I made. And that'll be the last thing for this video. Again, there will be more supplementals for this because I know I'm doing a little bit more detailed and complicated stuff sometimes. Definitely let your GAs know to let me know if there's anything in particular you really want to see. But essentially, all I did to make these is drafted up approximately what I thought this profile would be. And I didn't really actually get that exact. You know, I knew it needed to be about, say, 3 inches deep overall, whatever it may be, it's fine. It's not snapping right now. Come on. There we go. So once I have that curve, I'm just going to fillet the edges and set my fillet to 1/4 inch, which is actually already set to that. And select one side, select the other, select one side, select the other. So fillet will round the curve. Alternately, you wouldn't want to do this in this case, but chamfer, which we'll set to 0.25 as well. If you do select chamfer, why isn't it chamfering? Oh, okay, I'll try that again some other time. I just want to be finished with this video, as I'm sure you do too. Offset, we'll do 0.25. I currently have cap turned on. So you can see here, basically it makes that profile. This I would just make into an extrusion, but the way channel glass actually fits together is that the two pieces fit together like so, like you actually see below. So kind of like that, but they need enough space so the next one can fit into it. So we'll add 1/4 inch here. And now, essentially, that is how channel glass works. So each one of these you would want to extrude, and it's a glass profile. You know, as you can see here, it stores a nice air pocket in there with sort of minimal thermal breaks between them. Makes for a great wall, really cool little material. So you'd want to use, you know, I would probably take these two things and let's go to unhide some stuff. So I'm going to look at this in comparison to the section here, pull it up to where I know it starts, extrude it to the height that I know it needs to be, which is right there. And then once I have that extrusion, select those and make that into a block because it's going to be repeated over and over again. So might as well do that now. And click channel. And now you can array this and make the wall that we see here. Okay. Again, I will do some more supplemental videos, but I think this should be enough to get you started. Tried to cover what I thought was going to be the most complicated piece of each building. Of course, there's a lot of other things to do. So as you run into issues, let me or your GAs know, and I'll try to make some more videos. Thanks.